Alright, so in this video we're going to walk through this cars analysis Python file. So we'll be doing a lot of analysis looking at linear regression and then also residual plots, and then we'll look at some pair plots later as well. So here we can just import all of our packages. So we'll need matplot library, numpy, pandas, and seaborn, right? So we can just import all these. Okay, now we need to import our data. So in Canvas, you can find this auto mpg CSV file, right? So I have it located over here. So I'm just going to take this. And I'm just going to click on my files, right? And then I can just drag and drop this in, right? I'll just drag it in there. And now I can click the three dots here and just hit copy path. And now I can just paste that in here, and it should work just like that. Cool. So now if I want to show kind of like the first 5 columns, that's what we call the head. I'm sorry, the first 5 rows of our data frame, right? So we just imported this CSV in as a data frame in Google Colab. So we can do auto.head, right? And we can just run this, and it should give us the first 5 rows of our data set, right? So if you haven't taken a look at this CSV file yet, we have, we're basically looking at miles per gallon versus all these other variables. So we've looked at this data set before, but we want to see how does like the number of cylinders, how does the weight of the car, how does all this stuff influence the fuel efficiency. Okay. So we can create some scatter plots, right? So for plt.scatter for here, we just need to create a scatter plot of weight versus miles per gallon. So what we can do is we need to do weight, right, is my X, and then miles per gallon can be my Y. So we need to do auto, right, the name of the data frame. And then in brackets, we can type in our column names. We can go weight, and then we can go comma, right, auto, and then miles per gallon, right? If we run this, it should give us a nice scatter plot here. So we can adjust our figure size using this, right? We can add color. Let's make this like green, right? If we want to change the color of our points, right? We can adjust the titles and all that, but we get this nice relationship here where we've got weight on the x-axis and miles per gallon on the y-axis. So we see a clear negative trend, right? As cars are heavier, the less fuel efficient they are, and that makes sense. Okay, so what we're going to do now is we're going to create our least squared regression line using this np.polyfit function, right? So here we can really just put in our weight and miles per gallon attributes again, right? So we can go auto, right, and then just weight, comma, auto, miles per gallon, right? And this should store our M and B values, right? So this is really, we're creating like this, like Y equals MX plus B is kind of the form that we're creating, right? This is our linear regression where M is our slope, right? And B is our intercept. So in this case, right, we expect M to be negative, right? Since we should have a negative slope. Okay. Now for our y predicted, right, we can really just do like mx plus b, right? So we have m, right? So we're storing m and b. So the polyfit function, right, lets us save 2 variables, m and b. So we have these 2 new variables, so we can use these to create our y predicted. So we can do m times auto, and we can go weight. And then now all we got to do is plus b, right? So now it runs. It's not going to show anything, but let me give it a second as it kind of makes this fit. Okay, cool. So I'm going to add a block of code just so we can see what our m and our b values are. So M, right, we expect it is negative, like negative 0.007, right? So how we can interpret that is, all right, if the weight of a car goes up by 1 pound, we expect the fuel efficiency to go down by 0.00767 miles per gallon, right? Now, another thing we could look at is B, right? How could I interpret this value B, the 46.31? The way we can interpret that, right, that's my y-intercept if we were to draw my line, and we'll plot the line in 1 second. That's basically where I'm going to cross the y-axis when x is 0. So it's basically saying, all right, if I have a car that weighs 0 pounds, we predict it will have a fuel efficiency of 46.31. Obviously, that doesn't make sense, right? Because you can't have a car that's 0 pounds. Okay, so now let's plot this regression line, right? So we've got kind of the bones of our scatter plot. Now for plt.plot, right, we can just once again do auto weight. And then here, we're really plotting the x versus my y predicted, right? And this is going to create our least square regression line. So here, I'm just going to go y predicted. And then now you can give it a color, right? We'll go here. And let's plot this, and let's see what it looks like. Okay, so we see my least square regression line, right? It kind of fits my data pretty nicely, right? It goes through here. But yeah, so that is our line of best fit that we have. Okay, so let's move on. Now, one thing that we want to look at is our residual plot, right? Our residual plot tells us how healthy our line of best fit is, or this regression line is for our data, right? We'll talk more about this once I'm back. But remember, the residuals is really just the actual y value, right? Let me just type this out over here. Equals like actual y value minus the predicted y value, right? So for example, like this point right here is going to have a positive residual because the actual y value was like 24, right, miles per gallon. And the predicted, if we go down, we go straight down to this line, the predicted is like, what, 16? So the residual would be like +8, right? So it's 8 has a fuel efficiency of 8 miles per gallon more than expected, right? Where this one over here would have a negative residual, right? It is less efficient than expected. Okay, so we got to create this residual, right? So we can just go auto miles per gallon, right? My actual y values, right? And then here we can go minus like y predicted, right? Y predicted here. And this is my predicted, so actual minus predicted. Okay, so now for my scatter plot, right? So for the scatter, we really can do auto weight, right? So we will do my same x values, but instead of doing miles per gallon on the y, we can just do my new residual variable that we just created. Okay, so let's plot this and let's see. Okay, so we get our residual line here, and this red line here, that's this block of code that's doing this, right? That is just 0, right? So if I have a residual of 0, that means that I'm right on the line. So like these points will all be very close to 0, the residuals. Now, when we're looking at residual plots, right, we want to have a distribution of points that is completely random. We don't want to have any sort of trend. So if we look at this, do we see any sort of trend happening, or does it look completely random? I'd say there's some sort of kind of like curve here, right? There's a lot of values like right here, good amount like right here, not a lot right here, and then a big clump right here. So this tells us, okay, maybe this linear least square regression line isn't probably the best fit for this data, right? Because this relationship might have some sort of curve, right? We can kind of see it here, right? It kind of follows, maybe follows this curve. Maybe a curved line is going to be a better fit for our data. So it's because we're underestimating all of these values, right? We're overestimating most of the values over here, right? And then over here, it's kind of the same, right? So that's why we want to look at our residual plots, right? It tells us a lot about the health of our regression line. Okay. So now let's do something where we can look at our, what we call a pair plot, right? So pair plots, I think, are pretty cool. We can look at many different variables at once and compare a lot, and we make a bunch of graphs all at once. So here we've got all these other variables in this data set, right? So we were just looking at weight and miles per gallon, right? But what if we want to look at like cylinders or displacement or horsepower, any of these other things, right? So using a pair plot, we can kind of look at many different things at once. So let's look here. I'm just going to run this. We've got all these columns, so miles per gallon, displacement, horsepower, weight, and acceleration. And we can use this sns.pairplot. This is the Seaborn package that we imported in earlier. We can use this to create a very cool looking plot. So we can just go auto, and here we can just go calls, right? And this is going to pull all of these columns. So it would go like auto miles per gallon, auto displacement, auto horsepower, right? All of these variable names from here, right? All of these are in this list, and it'll be pulled here. So if we just run this, we should get a nice plot here. Okay, so we get a 4x4 grid, and all right, I'm sorry. So we can look at this here. So really, yeah, we've got miles per gallon, displacement, weight, acceleration. Oh, I guess it didn't include horsepower. I don't know why. But really, what we're looking at is we kind of have a scatter plot of each variable here. So this one, right, let's look at this one here. So this is miles per gallon on the Y versus displacement on the X, right? So we have displacement versus miles per gallon has a negative relationship, right? So it turns out, right, this graph and this graph are actually like the same thing, just kind of like flipped, right? Same thing with these two, right? And these two, it's just the axes are flipped because this is weight, weight versus acceleration, and this one is acceleration versus weight, right? So we can look at all of these relationships and we can see, all right, it seems like the ones that have the strongest linear relationship are probably like weight and displacement, maybe like this one here, right? We can look at all this stuff here. Seems like miles per gallon and acceleration don't really have too much of a great correlation. Now we notice we've got a bunch of scatter plots, and then kind of going along this diagonal, we've got histograms, right? Now the reason that is because you can't really do a scatter plot of miles per gallon versus miles per gallon, right? But we can create a histogram, right? So this is just a histogram of all of the miles per gallon of all the cars in the data set, just looking at the distribution. So it seems like all of acceleration is pretty normal, right? Weight is very skewed right. This is displacement, very skewed right, and then miles per gallon is just a little bit skewed to the right. So we can get a lot of insight when we've got many, many different variables by looking at a pair plot. And we can adjust the color. This was kind of just the default. Didn't even add anything, but if you want to play around with some of the other settings in here, go for it. You could also look up the pair plot option for some more customizability. Okay. So another thing that we can do is we can create what we call a correlation matrix, right? So correlation matrix basically just takes this correlation value R, right, that we've talked about, right, and that measures the strength of a correlation, and it's going to create a matrix similar to what we just made, but instead it'll be a matrix of the different R values. So real quick, I'm going to import this. We talked about this last week, the different color maps. Here's a list of all the different possible color maps that you could use. So if you want to go through these, go for it, but I'm just going to pick one. Let's do this one. And let's just go ahead and run this. Oh, what was the error? Let's see, could not convert string to float. What did I do here? Okay, so we were getting an error. Basically, it was saying that I couldn't convert my strings to floats, right? And that's because if you look at our data frame, or if you go ahead and scroll up, you could see that our data frame included a variable called car names, right, which was a string, right? And the correlation, right, you can only have a correlation between variables if they're numerical, right? So what I'm going to have to type in here is we're going to do auto, right, dot select, and then d types, and then in parentheses we'll say include equals, and then in brackets, right, we'll go number, right? And then now we can go dot core. Sorry, A little complex, but now if we run it, we should, oh, select, there we go. We should get our correlation matrix, right? So, and we can adjust kind of our color scaling here. So let me pick a different one. I don't know if I really like that one. Let's do cool. Okay, this one's pretty vibrant, right? But we get this nice matrix here, and we can see all the correlations between all of our variables here, right? So down the line, right, we should expect 1, right? Because the relationship between miles per gallon and miles per gallon is going to be 100% because it's the same thing, right? We see the ones that are kind of blue, right, have a negative relationship, and the ones that are purple and pink have a positive correlation, right? So the negative versus positive. So this is a really good way of kind of visualizing the relationships between many variables in one data set. Okay, I think that's good for today. If you have any questions, save them for me tomorrow, but enjoy your code.